let's look at the radius of convergence. Suppose I look at my series here. I want to know, where does it converge? It's entirely possible that I could have a series that only converged x equals c, where this whole thing becomes 0. It's also possible there's this interval about c, so c plus r and c minus r, where this will converge. And it's also possible that it converges for the entire real line. And as a matter of fact, the convergence of power series tells us that exactly one of these is true. That it either converges only at x equals c, and if r is positive, and in this case r is 0, where r is our radius of convergence. If r is positive, then it converges absolutely for x minus c less than r, and it diverges for all x greater than r, x minus c greater than r, or it could converge absolutely over the entire real line. So r is our radius of convergence. If it converges only at c, then, as I just said, r is 0. If it converges for all x, then the radius of convergence is infinite. Let's look at a few of these. Oh, actually, let's do a study tip first. To find the radius of convergence, use ratio test. It will really help you out. So suppose I want to find the radius of convergence. Sum of n goes from 0 to infinity of n factorial x to the n. Now, I want to look at any value of, I want to find what values this is true, but for where does this converge? So let me look at the limit as n approaches infinity of a n plus 1 divided by a sub n. All right, so let's see what this is. See, this is the limit as n approaches infinity of n plus 1 factorial times x to the n plus 1 divided by n factorial x to the n. Okay, so this is the limit as n approaches infinity of, let me rewrite this, as n plus 1 times n factorial times x to the n times x divided by n factorial x to the n. Now let me see what cancels. X to the n goes away, n factorial cancels. And so we're left with the limit as n goes to infinity of n plus 1 times x. Now you'll see it doesn't matter what value of x we have, except for x equals 0. All right? This is going to diverge. All right? So this diverges for all x where x does not equal 0. So the radius of convergence is 0, because the only value for which this is true is when x equals 0. Now let's find the radius of convergence of the sum of 3 times x minus 2 to the n. Again, I want to use the ratio test. This is the limit as n goes to infinity of 3 x minus 2 to the n plus 1 divided by 3 times x minus 2 to the n. This is the limit as n approaches infinity of 3 times x minus 2 to the n times x minus 2 divided by 3x minus 2 to the n. Now let's see what cancels. 3 is going to cancel, that's going to cancel. All right, now look at what we're left with. We're left with the limit as n approaches infinity of x minus 2. Now, I need this to be the absolute value of this. I should have thrown absolute value signs in there. Sorry about that. I need this to be less than 1 in order for this to converge. So when this is equal to Oh, this is just the absolute value of x minus 2 because I've gotten rid of all of my n's. So for this one, this converges for x minus 2 less than 1. So my radius of convergence is 1. Now, what happens if x minus 2 equals 1? All right, so what happens when, oh, let's not do that right now. Let's just look for absolute convergence.